In this lesson, we're going to sketch a whole range of absolute value functions. Now, just for the ease of being able to compare the different types, I'm going to every time use an example where I'm transforming the exact same parabola, so that way it's a little bit clearer and we can compare what happens when the absolute value brackets are around a different part of the function. Now, for the first one, we're sketching y equals the absolute value of f of x. So we're going to start just with a sketch of y equals f of x. Now, you'll either be given one in your question and you'll have to work from a graph, or you perhaps might be given the equation of y equals f of x and you can start by graphing that. Either way, the key idea here is that if we are taking the absolute value of the function of x, then that means that we only want positive values of y, because we know that putting these absolute value brackets around something makes it positive, even if it wasn't before. And that tells us that y must be positive. So, two steps. Keep everything on the original graph of y equals f of x that is above the x-axis. Keep that the same. Okay, so on this graph here, I want the sections that are above the x-axis, so I'm going to go over those. They're part of my new sketch. And step two, replace the sections that are below the x-axis, in other words this part, with their reflection above the x-axis. So we take a reflection here, which means it's going to bounce up something like that. So the part here in red is my new function, y equals the absolute value of f of x. So take a moment now to copy down this example and these steps. Now think back to the other absolute value functions that you've already learned how to graph. You've learned how to graph something simple like this, and really we did the exact same thing. We thought of the line y equals x, and we reasoned that we didn't want negative values of y, so this whole section here can't exist, and instead we get a reflection of that part up above the x-axis. The exact same thing happens when we have something a little more complicated in here. We've learned how to graph things like this, and that would just be a steeper line, of course, y equals 2x, and we've learned that it can't go down here, instead comes back up here. So this one should be the easiest of today's sketches to do, because we're already quite familiar with doing this, and now we've got a nice method written out that makes sense to us. Keep the section that's above the x-axis and make a reflection of anything that's below. Now let's sketch y equals f of the absolute value of x. Now notice here the difference is that the absolute value brackets are just around the x part. So again, begin with a sketch of y equals f of x. You might have been given it, or you might have to draw that yourself. The key idea here is that if we're putting absolute value brackets around the x, then any negative values of x, we're going to make the same, or treat them the same, as though they were positive values of x. So the key idea is that for any negative values of x, in other words, the numbers across here on the left-hand side of the y-axis, for any of those x values, they will have the same y value as their positive counterparts. In other words, if you're wondering what y value goes with negative 2, it'll be exactly the same as what goes with x equals 2. For x equals minus 3, have a look at what's happening for x equals 3, and that's where you'll go. So your three steps here, keep everything that's to the right of the y-axis the same. So for a graph like this, I want all of this part, because these sections of the graph have positive values of x. Okay, but I'm going to ignore everything that has a negative value of x, because that part of the original graph is not part of my new sketch. Step two, I'm ignoring these parts here, so I've kept everything to the right, I've ignored everything to the left, and now the last job is to reflect everything that you want that's on the right-hand side of the y-axis across the y-axis, so it flips onto the other side. And that ties in with our key idea that the negative values of x need to have the same y value partner as their positive counterparts do. So that means that we need to basically lock in some key points here, 1 and negative 1. I've got a 0 at 3, so I'll have a 0 at minus 3, and just get that shape roughly right. So my graph is sort of going to look like a big W in this case, something like that. And that whole section in red is the sketch y equals f of the absolute value of x. This time we're sketching the absolute value of the y equal to f of x. So, as before, we're beginning with a sketch of y equals f of x. Now, the key idea here, if we're taking the absolute value of y, then it means that everything on this side of the equation really can't be negative, can it? because the absolute value of anything has to be positive. So the key idea is that negative values of f of x on our original sketch are actually just not permitted, so we can ignore those. But we also need to consider that the negative values of y, once we do this to them, have the same x value as their positive counterparts. So a little bit like our absolute value of just the x, but the other way around. So using the same exact function that we've used before so that we can compare the strategies, our first strategy is to keep everything above the x-axis the same. And that's because we don't want negative values of y, but we do want the positive values. So let's start by going over the parts that we want. And we have everything above the x-axis. Okay, that's pretty good. Second step is to ignore all the sections of y equals f of x that are below the x-axis. So I don't want this curvy part at all, because it really just can't work with this formula. But I do need to reflect everything that I do want, the part that I've already drawn, that is above the x-axis, across the x-axis so that it can be down here. And that's because if I've got a negative value of y, let's say negative 2, it's going to have the exact same x value as positive 2 has. Because once I've taken negative 2 and done the absolute value brackets around it, it's going to give me the exact same thing as what I had with 2. And so that explains why I need to take each of these arms of the parabola and just find a point that it actually goes through and reflect it down. And then I need to have that basic curve down like that. So instead of going through 3, it will be minus 3. And I've got a graph that sort of has these two arms like this. And it actually has nothing at all in between here. So if you're looking at the domain of this graph, you'd say that x is less than or equal to 1, or x is greater than or equal to 3. And you'd say that the range is all real y.